In this era of energy consumption, the clear majority of the energy which we are in need of today is electrical energy. Our company, which manufactures transformers used for the transmission and distribution of electrical energy, is advancing on the path of being a pioneer of the industry. Through efficient and environment-friendly utilization of energy and by increasing our investments with each passing day, our goal is to provide the highest contribution to the welfare of the country and the world. The company manufactures cast resin dry-type and oil-type distribution transformers, as well as power transformers up to 220 kilovolts, 150 megavolt ampere at its factory. This facility boasts a closed area of 26,000 square meters, established on a 36,000 square meter surface at the Ankara-Sincan First Organized Industrial Zone. Our customer satisfaction-oriented company takes quality as our primary target for both manufacturing and service. All of the process of manufacturing in accordance with the aforementioned target are meticulously checked at every turn by our experienced and competent quality control staff. Our company is in possession of many management systems such as TSEN ISO 9001, TSEN ISO 14001, TSEN ISO 17025, and OSAS 18001. The completion of manufacturing is ensured in accordance with the related project and the quality management systems. Related non-conformities are eliminated with the implementation of corrective and preventative actions. All processes are recorded and tracked. Kaizen studies are conducted for the processes that require one by analyzing its accumulated data. Astor AŞ, with a monthly production capacity of 2,000 distribution transformers, boasts Turkey's largest capacity and ranks within the top 5 companies of the world in its field. At our facilities, we manufacture cost-efficient, safe, low-loss, long-lasting oil-type transformers with a power range of 250 to 2,500 kilovolt ampere and up to 36 kilovolt voltage levels, as well as custom-type transformers per customer demand, bearing the brand of Astor and EFG. Power transformers up to 220 kilovolts and 150 megavolt ampere, bearing the brand of Astor. Cast resin dry-type distribution transformers at the quality standard of ISO 9001 with a power range of 250 to 3150 kilovolt ampere, up to 36 kilovolt voltage levels with natural air-cooled or fan-cooled options, bearing the brand of EFG. Ranges of product and areas of use for dry-type transformers are given below: 160 to 3150 kilovolt ampere distribution-type transformers, monophase transformers, 4,000 to 25,000 kilovolt ampere power transformers, OLTC on-load tap-changing transformers, rectifier-type transformers, IP54 protection class, water and air-cooled transformers for submarines, marine vessels and oil drilling uses, wind turbine transformers, enabling maintenance and repair inside the tower, minimizes the risk of burning and explosion at locations with a high density of human habitation, such as subways, tunnels, mines, airports, shopping malls, schools, hospitals and skyscrapers. May be manufactured with an internal or external type cell as optional in conformity with IP20, IP23, IP33 protection classes. Apart from the aforementioned, our overseas type test reports for the product series within the product range are constantly updated and have been certified by the international accreditation testing organizations such as KIMA, IPH and CESI. The materials obtained in their raw form are converted to semi-finished products inside our facilities and are then turned into transformers by the skilled hands of our experts. The projects are prepared by our experienced design team under the leadership of over 30 engineers. We, as Astor Transformateur, are aware of the importance of R&D phases for our company and country. Therefore, a determined and firm step has been taken by our company to work with highly skilled personnel in order to own an up-to-date and comprehensive R&D center as of 2011. The duties of the R&D center of our company, which is passionate about always keeping track of world technologies, include increasing manufacturing efficiency and providing solutions for arising problems, developing the best and innovative designs in terms of functionality, performance, dependability, cost, and manufacturability, supporting the design and manufacturing process with analysis and simulations, preparing and keeping track of R&D projects, as well as providing training support for manufacturing manufacturing and design personnel regarding transformers. Our R&D Center has conducted and successfully completed many R&D projects in cooperation with Tubitak. Some of these projects are given below. Design and prototype production of SF6 gas-insulated transformers. Design and prototype production of high-energy efficient amorphous core distribution transformers. Design and prototype production of 63 megavolt ampere, 13233, 11.5 kilovolt dual low-voltage wound power transformers. Design and prototype production of 154 kilovolt transformers, resistance against short circuit generating from two conductors with different winding. Design, development and implementation of robotic source cell for distribution transformers body construction. Design and prototype production of PLC-controlled bobbin winding machine for transformers. Development and prototype production of a solvent steam drying system for transformers, as well as bullet train transformers. Oil-type transformers. Enamel and paper-isolated round and flat electrolytic copper and aluminium conductors are utilized for conducting material in windings of distribution transformers. The used insulating material is water and voltage resistant. The normal distribution of voltage surges has been ensured and strain of windings has been prevented with the implementation of special winding implementation in high voltage windings by means of increasing the bobbing inlet-outlet layer insulations. The windings of power transformers are executed as overtermed and layer winding depending upon the design conditions. Vertical and horizontal pressed systematic bobbin machines are utilized for the purpose of ease of manufacture for layer windings and elimination of gaps on the contact surfaces of windings. Winding processes are carried out by CNC-controlled automatic machines. Dry-type transformers. Tape winding technology, copper or aluminium tapes, are utilized for low-voltage windings depending upon the project design due to their technical advantages. Radial short-circuit forces are controlled through the utilization of special pre-resin impregnated material according to the desired isolation class between spurs. Bobbins are provided resistance against difficult conditions and excellent dielectric features by being subjected to hardening process following the winding process. High voltage bobbins are manufactured by use of copper and aluminium flat or round conductors with F or H class isolation depending on the project. Fine natural cooling is ensured within our designs by means of the effective dispersed cooling channels. Also, advantage is provided against high voltage surges. The core is manufactured from M5, M4 silicon alloy sheets with oriented crystals and a thickness of 0.30, 0.27 and 0.23 millimeters. Sheets with 45 degrees slanted cut at the transition regions of magnetic circuit. The production of the core is performed according to the project by cutting all of the sheets utilized within the magnetic circuit with CNC-controlled cutting machines. The cutting and alignment of magnetic circuit is performed with a method called step lap, which is useful for minimizing the iron loss. The nucleus is aligned with cross and longitudinal step lap implementation. CNC-controlled plasma and wave wall machines are utilized for the production of boiler. The welding operations of boilers are performed with CNC-controlled robots. CNC-controlled plasma machines are utilized for the production and cutting operations of transformer caps, and welding operations of the caps are performed with CNC-controlled robots. We are able to manufacture products with standard quality by minimizing human error through the use of CNC-controlled robots. Boilers, mounting and welding operations of which are completed are put through tightness test under compression. The suction resistance of wave-walled boilers are designed as 0.65 bar and of radiator boilers as 1 bar. The manufactured boilers are subjected to sandblasting operations if requested by the customer. Dyeing process is completed in accordance with the related standards. The boiler cap is designed for the extraction of winding ends. The parts are sandblasted following the leak checks, and the tank is prepared for dyeing process by means of chemical showers. These are prepared for use by first lining with automatic conveyor system and afterwards top layer electrostatic powder coating. The products with the highest quality, completely homogeneous and desired die thickness are meticulously put through quality control. Primarily, the bobbins are carefully placed on the nuclei in order to form the mobile part, and afterwards the laths are mounted to compress the core and nucleus for the purpose of stabilization and conveyance of radial forces. Then the upper nucleus is aligned and yokes are tightened. Thus, the possibility of movement of the transformer on the load is eliminated by increasing the pressure surfaces. The cap is mounted on the mobile part, and the connections of commutator and gauge ends are made with silver electrodes. Later on, AG and YG isolator mounting on the cap is completed with special gaskets by showing maximum attention towards oil leakage. With this process, the mobile part is prepared for firing. Heating and suction is applied with our drying ovens as the determined temperature in order to dehumidify the solid insulating materials of the mobile part. Thus, the maximum drying process is performed. The humidity and temperature values in our ovens are constantly analyzed and evaluated via the charts on the digital screens. After removing the mobile part from our drying ovens, it is placed within the boiler at the temperature of 20 degrees Celsius within 15 minutes at utmost. Oil filling is performed in suction environment at predetermined temperatures within the oil-filled suction ovens. Finally, the mounting process is completed by attaching accessories such as the indicator valve, throttle, thermometer, etc. on the oil-filled transformer and submitting to the testing division. Each of our manufactured transformers is subjected to routine tests at IEC 60076 TS267 standards at our laboratories, which have been accredited with AB 0650T accreditation number on 12/06/2013 by Turkish Accreditation Agency within our facilities. All the tests demanded by the International Electrotechnical Commission and Turkish Standards Institute, except mechanical resistance against short circuits for oil-type distribution transformers, dry-type distribution transformers and power transformers, are performed at our test laboratories. Our systems comprise the testing field of transformers with 150 megavolt ampere power and highest operation voltage up to 220 kilovolts, and transformers with 30 megavolt ampere highest operation voltage up to 36 kilovolts. Transformer routine tests. The following tests are routinely applied to every transformer manufactured at our facilities. Measurement of voltage cycle rate and control of voltage vector phase shift. Measurement of winding resistance. Separate sourced AC resistance voltage experiment. Induced AC voltage experiment. Measurement of idle loss and current. Measurement of short circuit impedance and load loss. Capacity and 10 partial derivative measurement. Measurement of DC insulation resistance. Transformer type tests. The following tests are also applied to the same type transformers if requested by our customers. Sound level measurement, lighting impact experiment, temperature rise experiment, fan or liquid pump loss measurement if fan cooling or liquid pump system exists. Transformer special tests. Apart from the services mentioned, the following tasks can also be performed if requested by our customers. Measurement of idle loss and harmonic components. Zero component impedance measurement. Partial discharge measurement. Insulating liquids. Breakdown voltage at power frequency. On-load tap changer tests. Function and isolation tests on protection, alarm, and remote control hardware. The transformers, as well as all manufacturing and test processes have been completed, are taken to the final mounting division. After the successful completion of the final controls, they are labeled and subjected to packaging process, ready to be shipped. Our customer service department meticulously examines customer feedback, prioritizing customer satisfaction. The planning of our customer service unit is completed to ensure 24/7 service availability. Our company, providing service to the electrical infrastructure of over 50 countries by virtue of our product and service quality, rightfully takes pride in the awards received for exportation.